Welcome back to the Deep Dive. This is the show where we take really dense technical stuff and, well, we boil it down to what you actually need to know.
Right.
And if you are deploying Salesforce Agentforce, or maybe more importantly, if you're studying for that Agentforce Specialist certification, then this deep dive is definitely for you.
That is absolutely right. Today, our mission is hyper-focused. We're zeroing in on the deployment lifecycle, the permissions, the security model, and all those, hidden architectural risks that can make a successful pilot just completely fail in production.
Right.
We're not just listing facts here. We're explaining the mechanism behind every rule. The goal is that when you see a challenge or a cert question, you understand exactly why a specific answer is the right one.
Our central theme today, I think, is structural maturity. We've learned that Agentforce isn't just an app you install.
No, not at all.
It's more of a catalyst.
Wow.
It forces your CRM architecture to be robust, to be ready for, high velocity, high concurrency work.
Yeah.
So we're breaking this down into 4 key areas. First, access control. Then data grounding and how things execute. After that, we'll hit the critical deployment mechanics and then finish up with risk mitigation and go-live readiness.
A full tour.
Okay, let's unpack this. Starting with the most fundamental building block of access control. Who can even run these new generative AI features once you've built them?
Okay, so when we talk about permissions in Agentforce, we really have to look at 2 different identities.
Right.
There's the human end user, your sales rep or your service agent. And then there's the automated agent service user, which is the system identity the AI itself runs as. Let's start with the end user first.
Okay, so we're talking about users who just need to interact with existing prompt templates. They're just clicking the button to get the AI text.
They're consumers, exactly.
This seems like a classic area of confusion on exams because you usually see 3 options, but only one is actually correct for that general use case.
It is. And the one you need to remember, the foundational permission set, is the prompt template user. Or, PTU.
PTU.
That's a permission set group you have to assign to any general user who's just going to be leveraging the AI features you've already configured.
So tell us what that permission specifically allows them to do.
The prompt template user permission set, it grants access only to run and interact with existing prompt templates. That's it.
So they're just consumers.
Exactly. Think of it this way. A sales rep uses the AI to draft a follow-up email. They're using a template you built. They're using the tool, but they don't have the keys to the engine room. They can't accidentally mess with the prompt or change the grounding data or, break the whole system config.
Okay, so let's compare that to the other one that always comes up, the prompt template manager. Where does that one fit in?
Well, prompt template manager is full admin authority. It gives a user the ability to create, edit, and manage the prompt templates themselves.
So that's for your admin or your AI specialist.
Right. Maybe a team lead who needs to update the prompt library. But for your, say, thousands of service agents who just need to run the template, it's way too much access.
It violates the principle of least privilege.
It does. And it also just creates a huge risk of someone accidentally changing a configuration that affects everyone.
So if you see a scenario question on the exam and it's asking what the general sales team needs to execute an AI prompt, the answer is always PTU, prompt template user.
Always, not manager.
Right.
And then there's the third option, the one that's usually just thrown in there as a distraction.
The prompt execute user?
Yes.
It sounds so plausible, doesn't it? It's got that perfect Salesforce naming convention.
It does, but you need to instantly flag it as wrong. That specific permission set, it just does not exist in Salesforce.
It's a red herring.
A total red herring. It's designed purely to test if you know the actual precise names of the access controls. Remember, it's either user or manager. There's nothing in between called execute.
Okay, so beyond just knowing the names, there's a really practical, very visible clue that a user is missing the right permission. What happens when a user who should have PTU logs in without it?
This is a critical point, both for troubleshooting and for the exam. If an end user is missing that required prompt template user permission set, the generative AI field icon, that little spark icon next to a field, it just will not appear for them.
So it's a visibility issue. It's not like they click it and get an error.
Exactly. The feature is all configured, it's ready to go, but the user's identity literally prevents the system from even rendering the button for them.
So if a user calls you and says, hey, I know we have the draft summary feature, but I don't see the icon, your first step is?
Check for the prompt template user assignment. That visual confirmation, or lack of it, is a direct result of missing access control. It's a clean binary thing. Icon is there, permission is there. Icon's missing, permission is not.
Okay, let's move from the human user to the engine room to the identity of the AI itself. This is where things get a bit more architecturally sensitive, I think.
For sure. So when you enable Agentforce, the platform automatically provisions a special non-human system identity. We call it the Agentforce Service Agent User.
And this isn't a person.
No, it's the security context for the entire AI operation. It's a dedicated execution identity for the system.
And this special user automatically gets a foundational security container.
Correct. It's assigned the Agentforce Service Agent User PS. That PS just stands for Permission Set Group, which is really just a bundle of individual permission sets to make it easier to manage.
So what does that specific permission set group actually do? What does it govern?
Its role is, well, it's comprehensive. It manages all the necessary access for the agent to function securely. This includes system permissions, all the necessary object access like read and write on case or contact, and crucially, field-level security.
FLS.
Right? The PSG defines the data the agent is allowed to see and use to build its response. The agent service user, running under this PSG, is effectively the system's trusted intermediary.
Okay, so here's a really common real-world scenario. My organization creates a new custom field on the case object. Let's call it preferred resolution method. The agent needs to see this to give better answers. What's the best practice for giving the agent service user access? Do I create a new profile, a new permission set just for this field?
Absolutely not. And this is a key governance point. The established mandatory best practice is to extend the access within this existing permission set group.
So you're saying I find the component permission set inside that PSG that controls FLS for the case object?
Exactly.
And I just modify that one element to grant read access to my new custom field.
That's it precisely. You modify the access component inside the provided PSG. You don't create separate profiles. You don't create new isolated permission sets for the service agent. You use the security mechanism that Salesforce provides, and you keep your modifications contained in that layer.
So it's simpler, it's easier to audit?
And it's the platform standard. It's a classic point that really differentiates an experienced, mature deployment from a rushed one.
That makes sense. You're treating that service agent PSG as a trusted central security hub that you fine-tune. You're not trying to duplicate it or bypass it.
You've got it.
We've established who can run the agent and what security identity the agent runs as. Now let's shift to how the agent actually gets smart and how it does its work. Let's start with data grounding, specifically when the agent needs to access knowledge from outside the immediate record.
Right. So Agentforce is built to give responses that are grounded in your own company's internal data.
So you don't get those generic off-the-shelf answers.
Exactly. And when an agent needs to access grounded knowledge article data at runtime, say in the Agent Builder or an Experience Cloud site, this process is specifically integrated with Data Cloud.
Okay, so why Data Cloud? Why can't it just query the knowledge object directly?
This is where we need to talk about RAG, or Retrieval Augmented Generation. Yeah. When an agent uses a RAG, it's not just chatting. It's performing a really advanced search across all your trusted data before it generates a response. Data Cloud acts as that unification layer. It pulls in the knowledge articles, other data streams, and creates this unified high-fidelity data model. The agent then queries that centralized data store at runtime.
Okay, so for the agent to be able to query that unified data store for grounding, there must be a specific permission required.
There is, and it's non-negotiable. The Data Cloud user permission set must be assigned to the Agentforce Service Agent user.
And what happens if you miss that? What's the failure condition?
Well, without that specific Data Cloud user permission, the Agent Service user identity cannot query the Data Cloud during runtime. The RAG process just breaks mechanically.
So the agent can't access any of the knowledge base.
Right. And the consequence is you get factual errors, you get generic answers, or you get what we call hallucinations, even if your knowledge articles themselves are perfect. It's a classic example of a simple security configuration completely blocking a core functional requirement.
That's a fascinating example of architectural layering. The AI depends on Data Cloud, which in turn depends on a specific permission set on the service agent user. It all stacks up.
It absolutely does. Now let's shift to internal data grounding record snapshots. This is when the agent is analyzing the context of a specific Salesforce record, like a case, to generate a summary. What determines which fields the agent is allowed to see on that record?
You'd think it would be everything on the screen, but the documentation is very, very strict here. Record snapshots grounding relies strictly on the fields that are available on the page layout.
Yes. the page layout that applies to that specific record and user at the moment of execution.
This is a nuance that catches a lot of even experienced Salesforce people off guard.
It does. And the reason is all about execution context. When the agent is preparing its response using ROG, it needs a predictable, reliable set of fields. The page layout provides that static blueprint.
Okay, so what common configuration elements, things we use every day in the modern Salesforce UI, are explicitly ignored by this record snapshots grounding?
This is one of the most vital technical details for the certification. It ignores two key modern elements. First, field sets are not involved.
Okay.
And second, and this is the big one, dynamic forms are explicitly ignored.
Wow. Dynamic forms are the new, flexible way to build pages. You can show and hide fields based on conditions. Why would the agent just bypass all of that and fall back to the old page layout structure?
It comes down to reliability.
Yeah.
The AI needs a guaranteed set of data fields, and the page layout is the most static, underlying structure of that record presentation. Dynamic forms might change what a human sees in the UI, but the grounding mechanism happens at an earlier, more predictable layer. It defaults to the underlying page layout to ensure consistency, no matter what your fancy visibility rules are.
So the practical takeaway here is even if you've moved entirely to dynamic forms, you still have to maintain clean, accurate page layouts underneath them.
Yes, you have to. If a field isn't on the underlying page layout, the agent cannot see it for grounding, even if a human user sees it on their screen. The page layout is basically the AI's data contract.
Okay, let's move from data grounding to action execution. Agentforce isn't just for summarizing things, it's for doing things, usually by triggering flows.
Right.
So when a custom agent action invokes a flow, say, to process a refund or check an order status, what's the default execution mode for that flow?
The flow is executed in system mode by default, and that's a really foundational architectural choice in Agentforce.
Okay, system mode implies elevated privileges. What does that mean specifically for security and access?
It means the flow execution itself is granted elevated permissions. And crucially, this elevated execution intentionally bypasses the running user's field-level security and their sharing rules.
They're FLS and sharing rules.
That's right. FLS determines which fields a user can see, and sharing rules determine which records a user can see. System mode bypasses both.
Okay, so let's walk through that. I'm a service agent, and my profile is really restrictive. I can't see sensitive financial fields on an opportunity. But I ask the agent to run a flow that needs that financial data to calculate a commission. What happens?
Because the flow is running in system mode, it completely ignores your restrictive FLS and your sharing rules. It runs as a trusted system identity. The flow can successfully access that sensitive financial data, do the calculation, and return the result to you.
Even though I, the user who started it, could never see that data myself.
Never. And that's the core purpose, isn't it? It ensures the agent can reliably do its job without being held hostage by the permissions of a low-privilege end user. The trust boundary shifts entirely to that agent service user's PSG we talked about earlier.
Right.
You have to trust that the permissions you've given the agent identity are secure, because the agent's actions through system mode flows will pierce the end user's security bubble.
So reliability in Agentforce is achieved by prioritizing system access over user restrictions. And that puts a huge burden of trust on the security configuration of the agent service user itself.
You've nailed it.
Let's shift gears now to the actual migration process, moving all this stuff from a sandbox into production. We need to talk about what I think is the most common failure point in automation migration, the flow deployment and activation trap.
This specific trap is almost guaranteed to cause a post-deployment incident if you're using traditional change sets. It's a classic.
So you build your custom action in a sandbox, it triggers a flow perfectly, you migrate the flow with a change set, you see the metadata in production, and it fails immediately.
Fails immediately.
The flow is there, I can see it. Why the failure?
The crucial non-intuitive point is that when flows are deployed using change sets, the metadata transfers, yes, but the flows are not automatically activated in production.
They arrive in an inactive state.
Exactly. This is kind of a historical safety feature of change sets, forcing an admin to manually review and activate it. But in the context of an agent deployment, if you miss that manual step,
What's the consequence?
the deployed flow is inactive. Any attempt by the agent's prompt to call that custom action will fail. It might be a silent failure, it might be an error. But the agent is expecting to call a runnable piece of automation, and an inactive flow is basically invisible to the runtime engine.
It just stops the process cold.
Yep. And it breaks the conversation flow for the customer.
So The necessary mandatory procedure after every change set deployment with flows is to manually activate the flow in production immediately.
It is the final essential step. Now, it is worth noting that more modern tools like SFDX or VS Code, they have options to deploy flows directly in an active state.
Right.
But if your organization relies on change sets, and many still do, you have to budget time for that manual activation. Ignoring it is a guarantee of a critical service interruption.
Okay, let's move on to another key generative feature that has its own deployment checklist. Work summaries for enhanced messaging. This feature lets the AI summarize conversation transcripts. What are the essential configuration steps that you have to do in the sandbox and then migrate together?
Work summaries needs three things to work in coordination: data storage, process execution, and visual display. If you miss any one of these three, the whole feature either breaks or it generates data that nobody can see.
Okay, so the first component is data storage.
First, you have to create custom fields. The AI generates structured output, right? The issue, the resolution, and the summary. That data has to live somewhere.
So you need to store it on the messaging session record.
Precisely. You need 3 dedicated custom fields to hold that AI-generated text.
All right, so the second component handles writing the data into those fields.
Correct. Second, you must create a quick action. This action is the trigger. It's configured to update those custom fields you just made. The agent needs a specific mechanism to take its generated text and commit it to the Salesforce database. The quick action is the bridge.
I remember it running into an issue once where we deployed the fields and the wrap-up component, but we completely forgot the quick action.
What happened?
Well, the AI was generating a perfect summary, but the system had no way to write the data to the fields. We spent days debugging what was basically a missing button.
That's a perfect real-world example of how the 3 components depend on each other. The data is created, but the right operation is just blocked.
So what's the final component, the visual piece?
Third, and finally, you have to add the wrap-up component to the messaging session record page layout. This is the UI element, the physical container, that actually displays the summary to the human agent. If you forget this step, the AI works, the data gets stored, but the agent looking at the record sees nothing.
Because the display component is missing?
It's not on the page.
So the checklist for work summaries deployment is custom fields for storage, a quick action for execution, and the wrap-up component on the page layout for display. All 3 have to move and be configured as a single unit.
That's the recipe.
We've talked about how Agentforce operates with speed and system-level access. Now let's turn to the consequences of that. You've described Agentforce as a technical debt amplifier. Can you really unpack what that means for our listener?
This is maybe the most important lesson of any Agentforce deployment. Technical debt, it's all the shortcuts, the poorly optimized automations, the legacy code you promised you'd fix later.
Right.
With human agents, these issues might just be a little slowdown or an occasional error once or twice a day. They're tolerable.
But the AI operates very differently.
Totally differently. Agentforce agents operate at an extremely high velocity and concurrency. A human might handle 2 chats at once. An AI agent could be managing 50 or more transactions, creating cases, retrieving orders, all at the same time.
So that concurrency puts massive stress on the org's limits.
Massive. It ruthlessly exposes and amplifies every single flaw. Problems that were invisible before suddenly become immediate, systemic, org-wide failures.
Okay, let's start with the most critical governor limit risk that gets amplified. The Apex CPU time limit exceeded error. This is basically the clock running out on a single transaction.
The error you'll see is system.limit exception. Apex CPU time limit exceeded. Salesforce gives every transaction, every save, every flow execution a strict 10-second CPU budget.
Right.
When an agent performs an action, like running a flow to create a case, that single operation doesn't run in isolation.
It sets off a chain reaction of other automation.
Precisely. That one action triggers every piece of automation on that object. Apex triggers, other flows, validation rules, you name it. And everything consumes CPU time from that same 10-second budget. If you have complex, slow triggers, they become transaction killers.
So let's trace that. The agent runs a system mode flow. That flow updates a contact. That update fires an Apex trigger. That trigger calls a future method. An old workflow rule fires. All of that complexity is inside one 10-second window.
And now imagine 50 concurrent agent conversations, all executing that exact same complex stack of automation at the same time. The server resources are exhausted instantly. The budget runs out, the transaction fails, and the agent process just halts.
The AI is too fast for your legacy code.
Exactly. And the AI can't just pause and retry like a human can. the context is lost, and it's a catastrophic failure for the customer experience.
So what's the mitigation strategy? How do you stop your technical debt from paralyzing the whole deployment?
Mandatory automation refactoring is needed before you deploy. You have to audit everything. The strategy is really two parts: consolidation and optimization.
Okay.
Consolidation means moving multiple small flows or triggers into a single optimized execution. And optimization means using faster tools. You have to rely heavily on before-save flows because they are way more performant and use much less CPU time than, say, after-save flows or traditional Apex.
Okay, so that's the architectural prerequisite. Now let's hit the second major governor limit risk.
Yeah.
The too many DML statements, 151 error. This is a limit on database write operations, not time.
Right. The error is system.limit exception. Too many DML statements. 151. DML is your data manipulation language create, update, delete. The platform allows a maximum of 150 DML statements per transaction.
And this limit gets hit when agent actions, which often use flows, have what's called non-bulkified logic.
Exactly.
Can you give us a concrete example of non-bulkified logic inside a flow?
Sure. Imagine a flow that needs to update 20 related opportunity records on a case. A non-bulkified design might put a loop element around those 20 records, and inside that loop, they place an update records element.
Oh, I see where this is going.
When that flow runs, it executes 20 separate DML statements for those 20 records. If your agent action does just 7 or 8 of those kinds of loops in a single transaction, you've immediately hit the 151 statement limit.
And with Agentforce handling dozens of concurrent conversations, that logic just explodes the limit.
Instantly. So the core mitigation strategy here is boltification, even in a declarative tool like Flow.
So how do you do that?
You have to follow Apex best practices. Flows must be refactored to use collection variables. So instead of putting the DML inside the loop, you collect all the records that need updating into a single list, a collection variable. Then, once the loop is done, you use a single update records element outside the loop and pass it the entire collection.
So you use just one DML statement for the whole batch, whether it's 5 records or 200.
Right. And that's how you avoid hitting the 151 limit. It's absolutely crucial for reliable Agentforce execution.
We've covered the visible failures, the governor limits that throw an error and stop everything, but now we have to talk about what you called the silent killer: dirty data and hallucination.
This is by far the most dangerous risk, because it results in wrong answers and customer frustration without ever throwing a visible error message. The system thinks it's working perfectly, the agent gives a confident answer, but the answer is factually wrong because the data it's using is flawed. This is what destroys customer trust.
So what are the main data quality issues that Agentforce just ruthlessly exposes?
I see 3 major categories that really interfere with RD grounding. First, duplicate records.
Okay.
If the agent is trying to find a customer's history using their email, but there are 3 duplicate contact records, the agent often just picks the first one it finds. That might be the oldest, most incomplete record. The agent uses the wrong context and the response is wrong.
Okay, what's the second category?
Second is incomplete records. RD needs specific metadata to work well. If your knowledge articles are well written, but they're missing key index metadata or categorization fields that the REM model uses to filter, the agent just can't find them when it searches. The grounding fails because the record is incomplete.
And finally, the issue of inconsistency.
Third is inconsistent data. This one is subtle. Humans know that US, USA, and United States all mean the same thing.
Right.
An AI agent treats those as 3 completely distinct text strings. So if you're grounding the agent on region data, and half your records use one format and half use another, the RE mechanism will miss critical information, leading to bad filtering and incomplete answers.
So the lesson is you can't delegate data governance to the AI.
You can't. Governor limits will break your agent technologically, but dirty data breaks it functionally by making it confidently and systematically wrong. Pre-deployment data cleaning and standardization are just as critical as all the automation refactoring we talked about.
As we move into the final validation stages, let's talk about testing. The Agentforce Testing Center is a great tool, but running tests in a production environment that carries a pretty big and often underestimated risk.
It does. When you're running tests in the Agentforce Testing Center, if your target environment is production, you are operating against real, live customer data.
Right.
The key risk is in your agent actions. If those actions are designed to perform DML to create, update, or delete records, they will execute those actions against your live Salesforce data.
So if I design a test to make sure my action correctly creates a case when it escalates, I'm creating a real live case in my production org every time I run that test.
Absolutely. And then those test records have to be manually found and cleaned up. Or even worse, they inflate your metrics, they mess up your dashboards, or they trigger other processes like sending an email notification to a real customer.
So you have to be extremely cautious.
Extremely. Production testing should really be limited to read-only operations, or maybe test against specific isolated test records that you can easily find and purge.
Let's move from technical risk to financial control. AI usage consumes resources, which are tracked as credits. How do organizations keep an eye on the credit usage from all this processing and testing?
That's all managed through the digital wallet. The digital wallet is the central tool that tracks and displays credit usage for all your AI operations, both in testing and in production, across the whole org.
What kind of visibility does it give you as a business leader or an admin?
It provides essential visibility into the number of credits consumed for every major AI operation. Whether you're testing prompts in the agent builder, running custom actions, or just general agent interactions, this visibility helps you monitor costs and manage your AI usage budget.
Can you drill down? Can an admin see what specific component is costing the most?
Yes, and that's its most useful feature for optimization. The digital wallet offers high granularity. It provides detailed breakdowns by agent, by session, or even by a specific feature, like work summaries versus some custom flow you build.
So you can pinpoint exactly which new feature is consuming the most credits.
Exactly, which lets you do really targeted cost optimization and usage control.
Okay, finally, let's talk about the final gate, user acceptance testing, or UAT. This is where the business has to sign off. If we assume the AI itself is working perfectly, where should UAT focus in an Agentforce deployment?
UAT has to concentrate intensely on verifying the integrity of the AI human seam. The seam, that's the moment where the autonomous agent decides it can't help anymore and it needs to escalate or hand off the conversation to a live human agent.
Why is that handoff so critical to test?
Because the entire efficiency argument for the AI rests on that handoff being seamless. If it fails, the human agent has to ask the customer to repeat their entire issue, which negates all the time the AI just spent qualifying the conversation.
So what are you testing for?
You have to confirm 3 key things.
Okay, first.
First, data fidelity. Is the data collected by the AI accurately stored and maintained during the transfer?
Second.
Second, context preservation. The human agent has to receive all the necessary context. That means the full conversation transcript, any sentiment analysis the AI generated, a clear summary of what the AI already did.
Oh.
If the human agent gets a blank slate, the UAT fails. And third, seamless ownership. Can the human agent immediately take ownership and continue the conversation without making the customer start over? Failure at this seam is a guaranteed driver of customer frustration, and it will absolutely tank your project's ROI. You have to test every single handoff point.
We have completed a pretty comprehensive tour here, from the single correct permission set for an end user all the way to the systemic risks of technical debt. As we wrap up, what's the single most important conceptual takeaway for someone preparing for that certification exam?
The summary takeaway is this. Agentforce deployment is really an exercise in architectural readiness. The AI configuration itself, that's often the easy part. Success hinges entirely on making sure your underlying service cloud architecture is robust, secure, and ready for high concurrency. And that means addressing your technical debt and strictly managing the permissions of that agent service user identity because it operates with elevated privileges.
So what does this all mean? For the certification, it means you need precise knowledge of the mechanism, the how, and the why. You need to know that flows from change sets need that manual activation, that custom actions run in system mode, bypassing the user's FLS, that data grounding rigidly ignores dynamic forms.
Right.
And that the only true end-user permission for just running a prompt is the prompt template user. It's all about mastering the technical fine print of how this integrates with the platform.
It is. It also requires an understanding that Agentforce just shifts the scale of failure. A governor limit that used to happen once a month could become an hourly incident. That structural maturity is what separates a successful deployment from, well, platform paralysis.
That structural shift is a really powerful concept. When we consider how complex agent actions retrieve data and interact with external systems, we often turn to asynchronous patterns like platform events because they offer speed and scale.
Right. Platform events are used widely to break complex processes into smaller, manageable chunks.
But those platform events, unlike standard DML, they're not processed within the main database transaction. That means the operations they trigger cannot be rolled back if a downstream system fails. So how does designing a complex agent action that relies on these non-transactional platform events fundamentally change your approach to building process reliability, logging, and, most importantly, data recovery? That is the question that defines the true Agentforce architect.